One, two, Web3.
1, 2, Web3.
1, 2, Web3. 1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3. 1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3.
1, 2, Web3. 1, 2, Web3.
1, 2, Web3.
Greetings, developers, hackathon participants, and metaverse architects. Happy Monday. I hope everybody's having a great day today. We certainly are over at Morales, and I'm pleased to welcome you to another hackathon workshop. This time I'm here with Rahat of Polygon, and we are going to be going over some additional tips for you as you proceed in this hackathon endeavor. I'm going to welcome Rahat to the stage here. How are you doing today?
Doing good, doing good. Thank you for having me on.
Well, without any further ado, let's get right into your presentation here. I understand that you have some slides ready for us here on migrating Web2 browser apps to Web3. An exciting topic to be sure. The floor is yours, sir.
Thank you. Yeah, so as I was kind of like thinking about this workshop and like what I kind of wanted to convey, a lot of it really boiled down to like how do we kind of like improve the usability of like Web3 dApps for folks who are kind of like onboarding onto Web3 and coming into the space kind of brand new from the Web2 space. So I wanted to frame this workshop in kind of like looking at it from the other side. I feel like a lot of the times when we build things out, when we build something instead of a hackathon, you kind of like really focus first on the smart contract, getting that really, well thought out and built, and then you kind of like stick a UI on top of it. And I kind of want to challenge that a little bit. Like, what if we kind of like looked at it the opposite way? What if we had a UI, we had some type of user experience that already exists for people, and we added like the Web3 components on top of that? So this is all about migrating like an existing Web2 browser app to Web3. So quick thing, a little bit about me. My name is Rahat. I'm the lead developer relations engineer over at Polygon. Previously, I've been a front-end engineer and a freelance Solidity engineer. So I'm going to be able to tap into some of my front-end past for this workshop, which I'm really excited about. And overall, I've just been like an indie hacker / Web3 enthusiast. I tweet a lot about like different ideas and things I have that I'll probably never have time to actually build. So if you ever want ideas, feel free to grab any of them. And I've been sort of like a founder in the past. I have a lot of failed startups. So if you're in this hackathon to like build a startup or do anything in that sense, I can definitely tell you all the things I did wrong. Can't tell you anything I did right because didn't do anything right, but we're getting there. And these are just a couple places you can find me online. A little bit about Polygon. So Polygon is the leading platform for Ethereum scaling and infrastructure development. So we provide like a multitude of different solutions that you can dive into and use If you've already been diving into the Web3 space, you might be familiar with our premier kind of like solution, which is our proof of stake blockchain. We're going to be building a little bit on top of that today. We've already announced as well like a few really cool things coming up, including our ZK EVM, which is a zero knowledge solution. EVM compatible blockchain, which more information will be out about very, very, very soon. But I kind of want to pose this question to everyone to kind of like get your gears kind of turning as we go through this workshop. How different is Web 2 from Web 3? And you might be thinking, oh, there's a lot of differences. Like Web 3 is the future. Web 3 is like what we're building and moving forward into. But I want you to kind of remember these specific things as we move forward. Front ends still exist in Web3. Back ends still exist. You can make the argument that maybe your smart contracts can act as your back ends, but in a lot of cases, you're still going to probably need some type of server, some type of back end service in addition to your smart contracts when you're building, especially when you start building out like beyond your MVP and like when you're expanding out to like attract more users, you're going to need further like maybe somewhat traditional backends, but you're going to need something. And the most important part of this is that your users still exist. So you have to be building for your users. You have to be building experiences that are easy for them to be able to, experience with your application. We're gonna first start off with wallet connections, but before we dive into wallet connections, I just want to show you this really basic app. Nothing like really crazy going on. All this really is just a rock paper scissors game. So if I clicked rock, a little message comes up. I chose rock. My opponent chose paper. Unfortunately, I lost and they won. Let me try it again. Nobody won. Paper. I still have not won. I just want to get one win. Yes, I got a win. All right, cool. Amazing. So nothing like really fancy going on there, right? It's just a rock paper scissors game. And like, what if we wanted to kind of like take this and migrate it over to Web3? The first piece of that might be adding a wallet connection feature to your app. So let's take a look at a little bit of JavaScript code. This is a handle wallet connect function. I come from a background in React, so I kind of wrote this in a way that's like biased towards React, but essentially you can do similar stuff in like any front end framework. But this is a handle wallet connect function. It's leveraging the Ethers JS npm package. You could definitely take a look at other types of packages as well. But in this case, what I'm doing is making sure that the Ethereum object exists in the window, which means that they have some type of browser wallet, such as MetaMask. And as long as they do, I'm just grabbing that address. And after I grab that address, they're just displaying that, right? So how would that look like if I were to update my game? So I have a couple different versions of this game. What you saw there was like the Web 2 game, and I'm gonna use this Web 2.5 game. Let me go into my React app, and now I have this connect wallet function. Let me quickly the actual implementation of the code is not very different from what I showed you, but in addition to the handle wallet connect function, I just have this like conditional that says, hey, do we have some address saved? If we do, then display the game container, otherwise display this button. So right now there's no address saved, so I'm going to hit connect wallet. I've already connected to this app before, which is why it was so quick. But if you were connecting to this for the first time, your MetaMask would pop up and you would be asked for permission to actually connect to your wallet. But now I am displaying my Web3 identity onto this page. The actual game itself hasn't changed. All that's happened is that I've added this connect wallet feature, right? Cool. before moving into like a little bit deeper into what else you could do with this, I just do want to call out like another wallet connect pattern that I've seen many folks use, and is often used a lot. Again, this is very React specific, but essentially what's happening here is that I'm taking this handle wallet connect function, and as soon as the page loads, um, the handle of the connection, the wallet connection is automatically kind of like activated. So rather than me clicking a button, it just happens. And in like a framework agnostic world, you could probably just have some JavaScript that runs as soon as the user lands on a page, and then this function actually runs. What I want to tell you is that you really should not do this. Please don't do this. Um, this is a tweet like from a while back, but I have a little pet peeve. Being asked to connect your wallet as soon as you land on a page kind of sucks. I should be able to look around and decide if I want to connect first. Unless I actually know you 9 out of 10 times, I'm not going to use your DApp in this case. And this is something you should really remember when you're building out your solutions and like how you want your users to perceive your app. If they're coming to this site for the very first time and immediately they're being asked to connect their wallet, some people might be like, but why do you want to do that? Why can't I look around first? You want to give them the ability to give you that consent before they actually connect to your wallet. And on top of that, it kind of promotes like really bad, security practices. Like if we're training our users to like always just like as soon as you land on a page, hit wallet connect. Ooh, what's gonna happen? Like, what if they have to connect wallet and eventually they're trying to connect to something that's a little bit malicious? It's a security practice that we don't want to encourage. Some further considerations for wallet connections. In my example, I'm kind of like biased towards using like a MetaMask wallet. And that's really just for the sake of the workshop. I just want to keep things kind of scoped down and like to show you one specific user flow and use case. But in your applications, I highly recommend don't just focus on browser wallets. Abstractions are really, really nice. Consider using tools like Rainbow Kit, Wallet Connect in combination with things like WagMe React hooks, and just like make sure you're hitting different types of wallets, mobile wallets, other browser wallets, other hardware wallets, etc. You want to make sure that your app is accessible as possible for different types of users. So definitely keep that in mind. Make sure you're hitting a lot of different types of users. And again, just remember, I just really want to drive this point across. Let users choose to connect. Don't do this, and let users actually choose to connect to your application. So if you wanted to dive further into like a wallet connect and like the kind of opportunities and like abilities that you can like add into your application after the fact, once you have like this wallet connect feature added, you should definitely take a look at sign in with Ethereum, which was an initiative kind of started by like Spruce ID. In the description, you'll actually see like a link to that GitHub repo as well, and it's got a few different examples, like taking this wallet connection even further. Right, there are some front end only examples. There are examples with like a full stack, like a node application and everything in there. So to kind of like remembering the fact that yes, your smart contracts can act as a backend, but you'll probably want something a little bit more robust if you're doing something like keeping track of user profiles, etc. So here's like one example of like where you would want to bring in possibly a backend server in conjunction with your smart contracts to actually make a really good user experience. And really, there's some really cool stuff in there. Highly recommend diving in if you want to add like a sign in with Ethereum flow into your application. Wallet Connect alone is not going to give you an actual sign-in flow because you're not keeping track of your users or sessions or anything like that. So definitely dive into this here for further kind of building. So I have that rock paper scissors game, right? How would we actually bring that on chain, right? So I'm going to do a little bit of live coding, not too much, but I'm going to show you kind of like a very, very rudimentary basic example of like how you can bring rock paper scissors on chain. This is by no means like a very robust solution. which is why I'm live coding it. If it was something more robust, I probably would just like show you some code examples. But I've opened up the Remix IDE just to like quickly build out a smart contract. Not a lot going on here. Just importing hardhat console.sol in case I need to do a little bit of debugging. I have a contract called RPS, a constructor, which is not going to really take anything. But let's start off by building out an array of strings. And that's going to be a public variable, and we're going to call it choices. And that's going to have like our rock, paper, and scissors. Nothing too fancy, just declaring that initial array. And now I'm going to create a function called random. I want to be able to randomly choose one of these options inside of this array. So the way I'm going to achieve this is it's going to be a public function. It's going to be a view only function, so there's not going to be any state variables that are updated. It's going to return an unsigned integer. And basically, I want to get a specific index of the existing array, which just has 3 indexes in it. So this part I'm actually going to copy and paste because I don't want to spell anything incorrectly, but I'll go over this with you. So what I'm doing here is I'm taking the block.timestamp, block.difficulty, and the message.sender, taking all of these values and running it through like this ABI encode pact, which will return some amount of bytes, and will then like be put through like the Ketchak hashing algorithm. So I'll just get this like random kind of like long string of numbers, and I'm just going to be dividing that by 3, and then getting the remainder of like whatever that division is. That's what this like percent thing here means. It's like a modular thing where I'm just like getting like whatever the remainder is. So the remainder will be either 0, 1, or 2. Now this is not the most secure way of actually getting a random number. In Solidity, you actually can't securely get a truly random number on chain. Like if you were going into a production environment, I would highly recommend looking at solutions like Chainlink, which give you like a verifiable random number. In our case, we're just doing this for like a low stakes game. We're not going to be adding any money to anything, so it's fine. But if you were to do this, have money attached to it, like let's say you were betting some funds and like adding it onto this like rock paper scissors game, somebody could make a malicious contract that actually is able to figure out what some of these details are, like what is the timestamp, block difficulty. These can all be figured out. One thing to kind of note that is special about this workshop being given this week. This week, as many of you may know, the Ethereum merge is currently in progress, slated about to happen at some point this week. And the way that like some of these values are calculated does change, and it makes it a little bit, I would say, a little bit more random, and like a little bit better in like getting an actual random number. However, I think the popular consensus is that you still want to use something like Chainlink to get an actually true verifiable random number. So just something to keep in mind, even like post merge. So this is just gonna give us a random number, 0, 1, or 2, one of those 3 values, or pseudo random number. And then like a very basic implementation of this might be that I'm just going to say, let's get a contract choice, which is also going to be a public function. It's going to be view because again, it's not going to change anything in state. And just going to return the choices at that random value. And let's just really quickly, it looks like my compiler says I did something wrong and I spelled return incorrectly. Cool. Compiler is happy now. Let's just real quickly take a look at what this even does. I'm going to use for the environment. I'm going to use the Remix VM tool, which kind of like lets you use like a locally running blockchain to like test certain things out. So I'm just going to deploy this real quick and just see like what would happen, right? If I hit get contract, get like this rock value. Cool. So rock, scissors, paper, awesome, cool. So it looks like if I am, eventually getting random different, rock, paper, scissors values, amazing. So that part of the thing works. If I wanted like a very naive approach, I could even like stop here, integrate this into my app, and just say like, "Hey, I'm generating this on chain." That's not that fun, right? So let's take this a step further. This part I'm going to copy and paste because it's a little bit long. But I will explain the implementation. So again, I just have the rock, paper, scissors potential choices, and I have two state variables giving us the player wins as well as the contract wins. Same random generator function, and now I have this like little bit of a helper function that I created. So working with strings and solidity used to be a little bit of a pain, and I'm kind of like showing you the painful way of doing this. The latest versions of Solidity have some more like string functions that have been added to it, especially if you're like concatenating strings. But I think you're still going to have to do this for actually like comparing them. So if we were to actually go ahead and figure out how to compare strings. Strings can't just be compared using like this equals equals operator. You would have to convert it first. So this is just converting it to a catch-check value. So rather than us writing this entire like thing out for every single string, I just like put this inside of a string catch-check formatter so that it's a little bit easier to read the code below. But what's happening here is like now I have this function called play rock paper scissors. It takes a string in memory called player choice and it returns another string. The contract choice is put inside of this variable. So the choices and then random that we tried out before. And now we just look at like a bunch of if else statements, right? So if the two values are the same, a draw occurs. And then I'm not going to go over like rock, paper, scissors. Hopefully y'all can kind of like get or appreciate like, how rock, paper, scissors works. But I'll just go through one of them. So if the player decides to choose rock and the contract choice is scissors, then the player wins count is turned up and we can return the player wins and etc. If it's paper, it's the other way, and all of the other if statements kind of show you like all the other possibilities of rock, paper, scissors. So now what we're doing is like we're kind of like bringing this like further on chain, right? We have our view functions as well as this public function that actually updates state. So it's no longer just a view. And it'll return you some string and also allow you to like keep track of like the player wins and contract wins. Cool. So I'm going to go ahead inside of my React application, remove the Web2 game, and let's take a look at a Web3 game. So it still has that connect wallet feature. Cool. I'm going to hit rock. And you'll see, unfortunately, my opponent won once again. But now, in this specific implementation of that code, what I did was like I calculated everything, and then I have a functionality to actually save it. So this is some pre-written code that I attached to this React application. But that gives you an idea of like how to incrementally start adding like different features to your Web2 UI, and really just go from there and like adding, what makes sense. What parts of Web3 do I need to like really take my app to the next level to make sure that it makes sense within the context for how my users are actually interacting with this application. Cool. So talked a little bit about that. Here's now like another fun app with an example on how to actually like connect your UI to a smart contract. So this this is like a little bit of a Pokemon battle simulation that I coded out. As you can probably tell, I love learning through just like recreating different pieces of like games. In this, so I'll just do the quick demo and then show you the front end code. But essentially, pretty similar to the last step. Instead of doing the rock paper scissors, I'm just like attacking using flamethrower, accepting some bit of like gas fees that I have to pay, and then the attack is happening, HP, hit points, and all that stuff gets updated. State variables are updated on the back end. But how does that work? How do we actually connect to a contract? So this is some code that you can add into your front end. The main thing is like first grabbing that contract address. Where is it actually living on the blockchain? The second thing is an ABI. Quick way to get an ABI if you're developing on Remix is to go into the compiler, hit this ABI button. You can copy it and drop that into your app. In my case, I had this in like a JSON file. If you're unfamiliar with what an ABI is, ABI essentially allows you to, it gives you like this large JSON file that has all of the information about the functions, arguments, and the different capabilities of your smart contract. When you're trying to interact with a smart contract from a front end that uses, something like JavaScript itself can't really directly execute a lot of the functionality that is in a smart contract. So I view the ABI as kind of like a map. What can JavaScript do to actually go through and like execute certain functions? It needs to know like what actually exists in those functions, and then uses some library to help you execute those. So the ABI kind of just serves as like a map or like a listing of like all of the different functions inside of your smart contract that are available. Again, in this example, it's going through using the Ethers npm library. So we have like, this is literally straight taken off from the Ethers documentation, just grabbing their provider, signer, and connecting to the smart contract using the contract address, the contract ABI, as well as the signer. So whoever's actually interacting with the app at that time. And then from there, we now have access to run all the functions on the smart contract as if they were kind of like JavaScript functions. In the case of this smart contract, I had the attack functionality. So I could just like go into the battle contract, say Lugia battle contract dot attack, execute that function. And further functions just included updating and getting the current HP of each of the Pokemon. So this is really all you kind of like need to start connecting to your smart contract and start executing it from your front end. So going a little bit beyond the initial migration, right? At the beginning of this application, of this workshop, what I told you was like, I wanted to help you all kind of improve the overall user experience of someone who's using your DApp, right? So that's why we kind of framed it and looking at it from like the user experience first, and then thinking about what smart contracts you need to build to actually power that experience. Going a little bit further and using Polygon to like kind of like even further supercharge your dapp's UX is using things like Gasless meta transactions. If you remember and recall, like if I wanted to save the result of my rock paper scissors game, I had to pay some gas to do it. If I wanted to get like even like if we looked at the Pokemon example, if I even just wanted to like execute a function to like run the attack, I had to pay some bit of gas. If you're thinking about figuring out how to onboard new folks into your Web3 apps, especially if you want to like, go into the, like a lot of us are now kind of like thinking a lot about like, how do we bring Web3 to the masses? How do we actually push things so that people can actually come in and try out our applications and get a broader audience? Because to be honest, our audience compared to like a traditional Web2 audience is a fraction of the size. So if we're trying to onboard new users, a good way to do that is using something like gasless meta transactions. In Web3, the concept of like a try before you buy or like a free trial doesn't really exist, because no matter what, you need some money for gas. You need to pay for your transactions. Um, One way to like kind of like go past that experience is gasless meta transactions. It's a little bit of a map on like how the overall flow works, and I'm going to go into each of these in the next couple slides. But to give you a full idea, you sign a transaction with your wallet, and it uses an EIP called 712, which we'll take a look at a little bit further. But you sign a transaction, you make some HTTP requests to some endpoint, and that endpoint is on a relayer, something like OpenZeppelin Defender or Biconomy. That relayer, what it does is takes that transaction, takes some, if you're on the Polygon blockchain, it'll take some amount of Matic and add that Matic to the transaction, right? And that way, your user doesn't have to worry about the gas. You can like preload this relayer with some amount of Matic, and for some amount of users that you decide, you can then say, hey, this person is new, maybe they don't have to pay gas, let them just execute this transaction gas free, and let them start using your app. So the relayer takes that request, takes the transaction, wraps the transaction with the amount of gas needed, sends it to the contract, and then the contract executes the transaction on behalf of the user. So if we were looking at maybe doing like a free NFT mint, right? All the user would have to do is have a wallet, connect, verify the signature, and then that verification would be sent to the relayer. The relayer would actually execute the transaction. Now the user gets an NFT without it could be a free NFT and without having to pay any gas or anything. And now they're already onboarded onto like maybe your community or being able to like use some of your services just based on that. And they didn't have to like go through the experience of like going on some exchange, buying some Matic for gas, etc. And like you kind of like eliminate a lot of the friction that people have for getting in and using your apps this way. So let's talk about EIP 712. What this does is allows you to create sort of like a data structure for your signature, kind of like a JSON object. And if you're using Ethers, the implementation of this is in the method called sign type data. But essentially from a JavaScript front end, all you're really going to be doing is, grabbing some data. Maybe there are some arguments that are needed specifically for this specific user. Maybe you want to, add some information to the metadata of an NFT. Maybe you want to like track some data about that person or whatever. And that would be taken from, the front end, and it can be inputted by the user. You just take that data and you sign, you create the sign type data. MetaMask will pop up allowing you to sign the data. And then you send it to a relayer using an HTTP endpoint that is given to you by that relayer. So something like OpenZeppelin Defender, Biconomy, Ethereum Gas Station Network, all of these are like different ways of like creating a relayer. But once you set it up like on any of these services, essentially you'll get an HTTP endpoint, right? You make a request. You make sure that there's funds that are loaded up for gas, and that's it. That's really it. The relayer takes care of the rest of the work for you and executes the transaction. One really cool, like in the wild, kind of like if you want to see this implementation used in real life, is if you take a look at Lens Protocol. If you use any of Lens Protocol services, if you use any, like a lot of the different products that are built on top of Lens Protocol, you'll see that you don't have to pay any gas to actually post, like, or follow anybody. But these are all based on like NFTs. They create little NFTs that like track all of these pieces of data for you, right? And the cool thing is like all of this data is saved on the Polygon blockchain. Technically, you have to pay some gas, you have to pay some matic to actually get those interactions on the blockchain, right? But because in the background they're using services like a relayer, you don't have to worry about that as a user. So you can like go in and like now you have the capability of using a social media platform that is built on a blockchain that has the benefits of being in a Web3 kind of decentralized area without you having as a user to pay for gas. And Lens like takes it like way to the end point where like they cover everything, right? Um, and this helps you like really improve the user experience of your apps even further, right? You started building the UI, you added the smart contracts based on that UI, you take it further with gasless meta transactions, and all this becomes economically viable on a blockchain like Polygon because of those lower transaction fees. But yeah, again, my name is Rahat. I'm the lead developer relations engineer at Polygon. Again, just a few places that you can catch me. It's been amazing to be able to be on this platform and share some of this knowledge with you. If you did enjoy this workshop, I'd really appreciate a shout. If you're like active on Twitter, tag 0x Polygon Devs or me at Rahat Codes, and would love to take this opportunity now. Maybe I think there's a question or two in the chat. Would love to answer those. But yeah, thank you for this. As far as, so I did see just like one question in the chat. How can I find the owner of an NFT? There's a few different ways to go about this. If you are, let's say you were building like an ERC 721 token, there are specific functions in like the ERC 721 standard that'll help you find who owns an NFT based on the token ID of that NFT. I don't know specifically the function like right off the top of my head, but if you take a look at the ERC 721 standard, that's one way. There are also like a lot of different APIs that exist out there for you to tap into to look at who owns an NFT. And you can also use things like subgraphs. So if you've ever used the graph, that's another like really cool way of doing that. Cool. I'm actually going to stop sharing my screen, so maybe it'll just be us. Yeah. Cool. Can relayers be used on the BSC chain, or would it be too expensive? I'm not too familiar, but I'd imagine that yes. I mean, the actual concept of a relayer, yeah. It you don't need to be on any one specific chain to use. You would just need to like look into like kind of like the economics of that kind of on your own. I'm not someone who can give you financial advice, so yeah.
So I had a question here as well. And thank you so much, Rahat, for a great workshop there. I was just noticing in the beginning, we were talking a little bit about making sure that our dApps don't immediately prompt our users to sign it or to connect their wallet as soon as or before the page even loads.
Mhm.
But I was wondering, what's the rule of thumb if we're creating a token gated site? How much of the site is it, maybe good etiquette to reveal even when you're trying to basically paywall most of the content? And do you have any thoughts on best practices there?
I would say like you would definitely want at least some introduction to like what's gonna be beyond that paywall, right? If you like, this is a terrible example in my opinion, but if you look at like different news sites and things like that, they kind of give you a little bit of the article and they're like, oh, you want to read the rest of the article, come sign up and do this and that. um I hate that experience. I'm sure many of you have like come to hate that experience as well, but maybe not going that far of like kind of like dangling the carrot in front of people, but like just giving them a summary of like this is some of the stuff that exists behind this paywall. You get access to XYZ article. The real thing is just like letting users know like why should they connect, right? Why should I give you access to my wallet? You know, um, and that's really the main point that I kind of wanted to get across there is just like let people decide on their own if they want to or not. Cool. I had a question: who pays gas for meta transactions? So that would be the developer, the company that is building out this actual app. So, like in the case of like let's say Lens Protocol, they're essentially like paying for the gas cost kind of like upfront. I think they have like certain grants or things that kind of like help get through that process. But yeah, at the end of the day, somebody has to pay for gas, right? It's not just like this, you put in a bunch of code and all the gas goes away. No, you're just taking the responsibility away from the user to give them a better experience on like onboarding into your app. Um, so you'd still have to pay for gas. So in the case of a relayer, you would like preload the relayer with whatever amount of gas like makes sense for you. Cool.
All right. Do we have any other questions here while we're still on YouTube? I didn't mention earlier, but I'll go ahead and let everybody know now. Following this live stream, we're in Gather Town. Click the link below in the description. You can join us. It's a virtual environment where we can talk a little bit about the workshop we just went through. We can also discuss other workshops we've had for this hackathon and really just kind of chat about where everybody's at in the hackathon.
Cool. Got another
Got another question here. Actually, I see a couple more.
Cool. How long did it take you to learn Web3? How long have you been with Polygon? I'd say I'm still learning Web3. I think pretty much all our things are like constantly changing. There's new stuff like literally every day. People are putting out new protocols, new ways of going about doing certain things. I've been, kind of like learning more of the technical side of things for about a year and a half now. And I was previously an engineer, I guess, in the Web 2 space, and Web 3 kind of caught my eye, and I feel like I guess I felt comfortable talking about it. Um, Maybe like 5 or 6 months in after I'd like learned at least some of the basics and tried to like ship some of my own products, some of my own smart contracts. So I think maybe a good way to like look at it of like how long it might take you is not how long it takes you to learn like all of Web3, but how long maybe your journey will differ from mine. Like, look at how long is it going to take me to ship something? It can be something, it doesn't have to be like the most complex thing in the world. As long as like you have some type of smart contract, you go through it, you think through it. Not even a smart contract, maybe you're building UIs for smart contracts. My very first job in the Web3 space was as a front-end engineer, building UIs for smart contracts. So um, it depends on like where your journey is, where you're at, like what your goals are, on like how long that's going to take. And I've been at Polygon for about 6 months now. Yeah.
So it's an interesting question when we get like, how long have you, or when did you learn Web3? And it's like, we're building Web3 right now.
Right.
So
Exactly.
even if I was, some kind of guru and I could come out here or either of us and say, oh yeah, I know Web3. If we don't keep learning things every day, we won't know it in 6 months. And that's both good and bad, because it means if you're getting started with us today, you might feel like you're behind, but just stick with it. I mean, the more you build
Mhm.
with these new tools, new networks like Polygon, tools like Morales, the more you become ingratiated to that way of thinking and building, and it just kind of builds from there.
Yep, exactly. Awesome.
Got a comment in the chat here. I'm going to put it up because it's good. Sometimes you just have to start and you'll figure it out.
Definitely.
That's
Yeah.
true. And building on that, we're here to help you figure it out. If you haven't already joined our Discord, there's a link in the description for the Morales Discord. It's morales.io/Discord. Join us there. The community engineers led by Yosef are there to help you get going with your dApps. Also, if you're looking for more of a just to chat before you get started or about what you're building, join us in GatherTown, like I mentioned. And we'll be there for at least 45 minutes to just chat about anything and everything that you're building right now. I'm going to take one more question in the chat before we take about a 15-minute intermission, and then we'll see you in GatherTown.
Cool, a spicy question.
This is a tough one, but I'm gonna take it because Polygon is a sponsor on this hackathon and Solana is not. And for the record, we would love to have Solana as a sponsor on any hackathon. So we're not excluding them in any way. We do support Solana as well. But that said, I'm happy to give you the floor here to talk about maybe one of the advantages developing, or a couple developing on Polygon over Solana.
Yeah, I mean, definitely if you like look at like the, I guess, current the Ethereum kind of developer ecosystem is definitely like the largest ecosystem in Web3. So if you're looking at like wanting to make sure you have a lot of like different tools available to you, a lot of different support, and just like a really large support system of like different developers, the Ethereum ecosystem is where you'll probably get that. And Polygon's an EVM chain. So all of like we literally build off of like the existing largest developer ecosystem that is here in Web3, and everything that you're already building. Like if you're already building an EVM, if you're already building on Ethereum, you know what you need to know to like build on Polygon. So you just couple that with like faster transactions and cheaper fees, and you're kind of good to go with like scaling on top of it. And there's use cases, I'm sure, for both sides. I don't know too much about like the Solana ecosystem, but yeah, I mean, you gotta look at like your users, your trade-offs. Where are your users based? Are your users already onboarded on Ethereum? Then Polygon's probably a good choice because they don't have to learn much more. So you got to look at kind of like the bigger picture of like where your users are and like where you need to target your app.
Great points, and I completely agree. I think for a lot of us, having dApps which can be deployed to multiple networks is a huge advantage.
Mhm.
And if you're one of those people, then working on EVM compatible chains gives you an amount of robustness that you won't have otherwise. Now, that said, I'm not here to discourage anybody from developing on Solana. If that's your flavor, please go for it. Now, for this hackathon, I think you're going to find some distinct advantages developing with EVM chains based on the tracks we have set forward. So a good change for a future event, but that's definitely giving you a little bit of an edge there, I think, if you stick with EVM. That said, thank you, everybody, for joining us for this workshop. Thank you, Rahat, and just look forward to seeing everybody over in GatherTown and at the next workshop. We've got 4 more left this week, so we'll see you guys at the next one.
Thank you all.